Problem 21 gives us this integral to solve. So when you see something like this, they're probably going to be testing you on either use substitution or integration by parts. So it'll be good to just practice some of these problems even outside of this packet, just so you can become familiar with what they look like and being able to identify if you want to use substitution or integration by parts. In this case, I would recommend using use substitution. This isn't an absolute rule, but when you see trig functions where one of them is to an odd power and one of them is to an even power, usually using use substitution, it'll cancel in a way that makes the integral easier to solve. So our first step is we're going to have to use some of our trig rules to simplify the equation. So first, I would use this rule right here, which I believe comes from the Pythagorean theorem. And we're going to be able to substitute in part of our sine part of this integral. So we'll solve for sine squared equals 1 minus cosine squared of x. And then we can substitute this into our equation. So we'll be left over with sine of x times 1 minus cosine squared of x times cosine squared of x dx. And from this point, we're going to have to decide what we're going to substitute in with our u substitutions. So I would set u equal to cosine of x, just cosine of x. And if you find the derivative of this, you'll get negative sine of x dx. And you might see where this is going. So if you solve for d of x, you'll have 1 over negative sine of x du. Now we can substitute in from here. So we have sine of x times 1 minus u squared times u squared. And if you subbed in for dx, you'll get 1 over negative sine of x du. And you can see exactly what I'm talking about here. This sine of x is going to cancel out, and we'll just get left with u's, which we can integrate for. So we get left with u to the fourth minus u squared du. And if you solve this integral, you get 1 over 5 u to the 5 minus 1 over 3 u to the 3. And then if you plug back in, you'll get your answer, which equals cosine 5x over 5 minus cosine 3x over 3. And this is your final answer. Problem 22 asks us to solve a very similar integral that problem 21 asks us to solve. And we can start the same way by substituting out a sine squared. So we get left with 1 sine of x times 1 minus cosine squared of x squared, because we had sine to the fourth that we're substituting, and cosine squared of x dx. Next, we're going to define our u substitution again as cosine x and du to equal negative sine of x dx, and dx will again equal 1 over negative sine x du. If we make our substitutions in here, we'll get left with sine of x times 1 minus u squared squared times u squared times negative 1 sine of x du. Make our cancellations just like before, and we're going to get left with 1 minus 2u squared plus u to the fourth, all times u squared, and there's a negative 1 in there, du. You simplify this, and you're going to get left with negative u squared plus 2u to the fourth plus u to the sixth du. This is going to be negative right here. And if you solve this integral, you're going to get left with negative 1 over 3 u to the 3 plus 2 over 5 u to the 5 minus 1 over 7 u to the 7th. And if you substitute back in, you'll get negative cosine cubed over 3 plus 2 over 5 cosine to the 5 minus cosine to the 7x over 7. And this is our final answer.